Imagine trying to learn how to ride a bicycle strictly by reading a textbook. You could memorize the physics of balance and the mechanics of the pedals, but the moment the wheels start rolling, gravity takes over. We know reading alone fails when teaching a physical skill, yet we frequently rely on that exact method for science and mathematics. We ask students to memorize complex engineering principles on a blackboard, hoping it somehow translates into real-world capability. Think of a traditional classroom as a highly detailed recipe book. It holds valuable instructions and exact measurements. But to actually learn how to cook, a student needs a kitchen. In the modern educational ecosystem, that kitchen is known as an Atoll Tinkering Lab, or ATL. An ATL is a specialized workspace established in schools under a government initiative to foster hands-on technological innovation. It serves as a dedicated innovation playground. Instead of sitting at desks reading about circuits, students pick up real screwdrivers, connect actual wires, and program microchips to build physical solutions for tangible problems. A school that stops at the classroom door provides the recipes but locks the pantry. To complete the learning process, students require a space to grab the ingredients and start cooking. Look at the layout of this typical Atoll Tinkering Lab. Notice the absence of forward-facing desks and chalkboards. The room features open, modular workstations designed to encourage students to stand up, move around, and collaborate. This diagram shows the specific appliances equipped in this new kitchen. Instead of stoves and blenders, the lab is stocked with 3D printers, do-it-yourself robotics kits, and basic electronic sensors. The primary activity utilizing these tools is tinkering. As you can see in this tinkering loop, the core curriculum requires students to build a prototype, test it out, watch it break, and figure out how to improve it. Watch this step right here, the break phase. When a robot falls over or a circuit shorts out, it is not an error, it is valuable data. The process requires students to make mistakes because those specific missteps show them exactly what to fix next. Through this cycle, the student stops passively consuming lectures. They become active creators, testing hypotheses with their own two hands and adjusting their approach based on physical results. Achieving genuine scientific literacy takes more than reading. It demands a structured, physical space where active experimentation is the goal and making mistakes is a required step for discovery. If you are a school administrator, looking at rows of 3D printers and microchips might cause some anxiety. Most educators are not engineers or procurement specialists. Sourcing to correct motherboards, reading thick technical manuals, and ensuring safe power requirements looks like a massive logistical headache. This is why schools utilize a setup partner like STEMrobo. STEMrobo is an educational technology company that acts as an expert kitchen contractor, handling the entire lab creation process. Their team manages the physical installation. They source the exact equipment required by the government mandate, deliver the hardware to your building, and safely install every soldering iron and robotics kit into your designated room. This graphic illustrates the partner's support streams. While sourcing hardware and curriculum are vital, the most crucial stream flowing to the school is teacher training. The setup partner ensures your existing teaching staff feels fully confident running the equipment. By utilizing a specialized partner, what could be a massive logistical liability turns into a completely effortless plug-and-play addition to your campus. Picture the fully operational lab on a busy Tuesday afternoon. The room is loud, filled with highly engaged students collaborating over wire cutters and code screens, while the principal looks on from the doorway, completely relaxed. The real value of the room hits when a student connects the final wire. Seeing a theoretical idea suddenly flash on in the physical world creates a spark of pride you rarely see during a written exam. For the school administration, the relief is knowing they did not have to invent the curriculum or engineer the technology. They simply had to make the decision to open the room. If you are ready to bring this environment to your campus, contact an ATL setup partner today to begin designing your own innovation kitchen. Your school already houses the bright minds of tomorrow. Your next step is giving them the right room to start building.